the filtration tank. Okay. So, our connection also this other gentleman is an expert here. So we are going to work with him hand in hand so that he can take you through how the science of this thing works here. We are working along with him. We'll show you how we generate biogas from it. We'll show you how we generate the liquid manure, the liquid what? The slurry. How we use the slurry. How we use how we transform the gas from a point where it comes from the cow dung up to a point where it is infiltrated inside here. How it is filtered out, so that we get to separate the gases, and we crop out the methane gas purely. Because we are for us, we purely crop out the methane gas. We don't use generally like those other gases you see other farmers are producing on the small scale. Farmers out there are using these other, you can use anything. But here, we have how many? Yes, methane. We use methane here purely. And we have its tank, and then he will show you how it runs from the tank up to the point where it goes to its generator. Because you have a generator that uses gas. That's the one that one. Now, when the gas engages there, it can generate the electricity that runs. That how you see it running, like how you see normally how a generator can generate electricity that could be used to run probably a station, a factory. That's why we are using gas. So you may see that generator think it runs on electricity. No, it runs on gas here, which comes from that tank, composed of the methane itself.
So here I don't have issues of women.
Come again?
Don't have issues of women here.
I'm not suffering. You see that now we are partly using this. And you see now we have a canteen there where they're cooking the food from. You see this system. This system now, all this gas, biogas comes from here. Connected going through underground up where we're cooking from. You actually, when I take you to the canteen, you'll be able to see that we are serious using this gas to cook 100% our meals here. We're not paying women bills anymore. One light,
Yeah, light.
I told my left darkness.
You left darkness?
Left there's no power.
Gas production. Then also, why is it that we use the what? What if we also add in it to the human waste? Does it change anything like chemically for the composition?
now, I see those tanks you are putting there. We're trying to see how when you mix wastes of different animals, even human beings, even the goats, pigs, what we are trying to make an experiment there to see how the composition is going to, which results that it's going to give us, how the levels of productivity, if in case we mixed cow dung manure, and in case we mixed goat manure, and the levels of productivity you get, and even clean one. That's why we have generated those small tanks you see. If you don't want to because things will not work out like we expect, and you wasted resources here. That's why we have cropped them out specifically to make sure we track what you're trying to ask. You get my point? Then why we put up this? Because we don't want here. First of all, we don't want to waste. You understand it causes the methane when it's overexposed in the environment. It causes what? Global warming. So we are trying. Why we set up this system? Because we want to trap. Being that we're having so many cattle we are handling, and then we have again put another bigger system there, and the other had bigger than this. That's going to track the cow dung in what? In the excess figures. You get. So we are trying to track that down. Otherwise, if you had found it here, they will be having issues of methane all over. And even waste, like I told you, this is a zero waste recycling plant, and we want to reduce all those. So the moment you trap it from here, we're able to crop out the other value-added products, which we get from renewable energy, which would help us, of course, first of all, to formulate up other natural products we can use on the market. Second of all, it helps us to mitigate issues of waste being wasted within the environment here. You get my point?
Yeah.
So then I'm going to have this gentleman here, is an expert in this place. Let us work together with him. He takes us through all the way how the agitator works to these points here, for how the gas is trapped is, because under here is where we trap the gas from. That's why you're seeing these small outlets where the pipes are. Let us listen keenly and then we ask him whatever questions we want when past this point. So he can introduce himself to you, and then he will tell you.
Is it a morning or just start?
Morning.
Good morning. I'm called Senkubu Ronald. I work here as a technician in the biogas. Here we have what we call a collection point. This system must be mixed automatically using the agitator. But here our agitator is down. They are repairing it. Now we mix it manually. We mix a small part of it. We place our pump. Then this pump starts to suck out. In the process of sucking, we find that there is excess water in that cow dung. We put the pipeline outside. It removes some water. When we reach at the project point, we start feeding our digester by putting the pump in the inlet. Those small buildings you are seeing there, we call it an inlet.
So you could understand why they are put this pipe here now.
Yeah.
They're trying to access water. You don't have to, and it's connected to a trench system there. Excess water is moving, being drained out.
Then it started to flow, the other side to go in the digester.
This one.
I think they can enter in because some of them have not had.
We use manual to mix the other side because the agitator has got some mechanical problem.
Now what about here?
Here we just place the pipe from the pump.
It comes.
Yeah, it fits here. Then it started to flow there. Down there is the pipe, the big pipe, which helps the manure to go the other to the digester.
So here.
What's the main purpose of this? To remove the excess water?
No. This one is called the feeder.
It's like inlet.
Yeah, feeding an inlet. It feeds the digester.
Then when you are feeding, it's supposed to be in form of water, yeah?
Yeah, it's supposed to be in the porridge form.
You also wanted to see? We have not seen. You come out.
If you're interested, and then you see what
Enter and see.
Some will come out. I want to stay there all the time.
You want to go with it?
You want to go with it? The pipeline which goes to the digester.
But not from the other house.
From the other side, you use the pump. You have seen the pipeline on the pump. Yeah, it's the one feeding here.
So you pass the other pump out here. This one here.
Yeah, it's supposed to be in the porridge form. A ratio of 1.
this cow down now has been cropped out in the water. Always they pump it. We have a system where we keep rolling, and that cow dung is pushed inside here. Down here is a point where it gets collected. It's like a compressor. There's no gas outlet there. So all the gas is formed inside here because here there's no outlet. But then we have put those small pipes you see, which are yes, down here.
It keeps on accumulating. If you don't add.
Now this digester you are seeing here is very big down there. It's like in the form of a pot. Like it contains like 120. Should be. That is the huge fixed
When your head is
you are seeing that pipeline, this one, it comes from the digester, it connects to the other digester, then it goes to the filtering system as you are going to see. Let us continue.
You have a question?
So connect for the cow dung. We'll try this the other side and those experiments you are seeing there. The cow dung I think is like 5 days.
To start making gas.
It starts making gas.
For how long does it make that?
Then how long does the cow dung spend here to be removed to replace it with another one?
Like
2 months, eh?
but for us, we keep on feeding.
Eh.
We have a lot.
One other question.
How does it use you have another system that pushes it, right?
So
You have another system that pushes it and pushes it.
we are going to see that one.
We have where we have
Somewhere. You should start this and start supplying electricity at your village.
Yeah, you see that tank. That tank is too big. That tank is full, it's too big.
The dome is also big.
But no.
Now here, we have what we call a drainage system. You'll find that
Nicola Blaza is there.
this gas reaches a time and forms some water. So last we have this drainage system to remove excess water that is not there. That is gas. Yeah, that's the only gas. In that gas, you will find that we have methane gas, hydrogen sulfide gas, and carbon dioxide. Oxygen is not there. We only have but for us we need what we call pure methane gas. Yeah, as he told you, this one goes to the cooking area. This small system we're seeing here, we can call it the filtering tube. This one we use what we call a stool wood, or you can call it a stool wire. We put it inside to remove that sulfide gas to avoid the rusting of the stove. Yeah, because that sulfide it leads to the rust. Let us go the other side.
After the sulfide is being removed, where does it go? Does it
The sulfide?
Sulfide.
The sulfide remains in the steel wire.
That's why we have put it there.
Yeah.
It's contained inside the steel wire. It has the capability to contain quite some time. Until when we can change it, put
We
in
change
one.
it.
So the steel wool is a maintenance item.
It's a maintenance item. We can just keep rechange. We shuffling it. Maybe you can advise on when you can change and when we put a new one, how long we can make to put a new one.
Take 3 weeks.
Because they'll use it every day.
Now this is our filtering system. We have the overflow meter as the other side is there to count the gases which enters the other side. This side. This one is called a flame arrestor. The flame arrestor helps us to remove the carbon dioxide.
How does it do to remove the carbon dioxide? Like how is the process? It uses a filter.
This one uses the water.
Oh, it passes through water.
It passes through water. Actually, the carbon dioxide remains in the water, then the other gases will soon go to the other side.
So this water is kept on, it's kept flowing, or you just put it once in a while.
We will put it once in a while.
Where is the inlet and outlet?
For the what?
The gas.
For the gas. This is the inlet. Then the outlet is there.
Then
This one is used to use
So how long do you take to
change your water.
to change the water.
But what service this?
For us, we change actually weekly.
So now here, after carbon dioxide is removed from here,
We remain with
the methane.
methane and hydrogen sulfide. We have what we call the hydrogen device. From the hydrogen device, it goes to the deferalization towers. We call this one the deferalization tower. This deferalization towers it contains what we call pellets. These pellets are looked like this. Yeah, they are looking like that. This one helps us to filter what we call the hydrogen sulfide. Instead of using the stool wood, you can use this one to remove the hydrogen sulfide. Then the hydrogen sulfide remain in this, the hydrogen tower. It goes to the pump. We have a pump there. We put it in case we are using our generators, you are going to see. Once the generators run, it needs something to help this to pull the gas from the digester, because you find that the gas is many, and the digester yet it flows to the low speed. It needs something to pull it. Then from the pump, it comes to the bath tank. From the bath tank, you find that there is some other remaining things. Then impurities. We have the final filter.
So this is that other impurities.
Yeah, other impurities. Then the final filter, it's on going to the other storage tank behind there, the green one.
So now this one is for carbon dioxide.
Yeah, it's for
Then the next one,
the other one for
this is small.
hydrogen sulfide. This one, then I just call it, just keep the gas. Just keeps the gas. Then it goes to the other side. The hydrogen sulfide
Then
remains here.
the other nitrogen sulfide.
Yeah.
This one is called.
That's the water tank. The Flamer Lester.
We go.
People invest.
People invest. This is the government. This is where your tax is going.
Now, when we are doing filtration, because the one now the pure gas.
It will remain with the pure methane. It goes to the other side in the storage tank. Yeah.
Okay.
Is it from the storage tank?
Yeah, the one is the one we use to run that.
Then after the filter, now goes to be used.
Yeah, it's
Storage tank.
Pure.
Yeah, we have a small compressor there, but you can't compress it in the ceiling because it's very weak.
After storage tank, electricity. Yeah. Or if you want electricity, or if you want to pump it.
Which one? The one here. We just open we close that valve, open it there and put a pipeline. It goes out, then we fill another one.
There's a drainage plug down there. Just this ordinary water.
Yeah, we add that one.
This to do water.
Yeah.
It's producing some powder, but it's not. So you're losing some gas.
No, you get like what the normally says. You normally pack. We have some,
I think experiments there.
You find that that compressor can't do that work. They are planning to build here a factory to run that process. Yeah, we use it to run this thing. Let me come and open for it.
That's where we are now.
6 cylinder.
This is a generator which uses compressed gas.
This is turbine engine.
Turbine engine? Hey man, where are you? Bring him here.
So go come and explain for that turbine engine.
Bring him here. Aken, where is that man? Hey, let him come here and get some stocks.
out of it. So we are recommending on the flex.
What is it about?
Tips in warming the
Exhaust.
Let me leave.
You're recording a full video.
How are you concerned?
No, I'm not concerned. I'm just yes.
I will read your subscription later. Don't worry.
Does not work. Forces air in.
So, I need your subscription.
Primary
6 cylinders.
so that you have enough air.
This is starter motor. Starter motor is fine. Normal generator. Yeah, kosa guli omuka. 6 cylinder. Mukolo oliko video. Yeah. Piston.